Good morning, student. Myself, Dr. Kapil Sharma, presenting a lecture number 1, Quantum Mechanics. Here, first of all, the content of this presentation, like first we discuss introduction, quantum mechanics. Another is blackbody radiations, Stephen's law, Wien's law, and Rayleigh-Jeans law. These are basic law that cannot explain on the basis of classical mechanics. Here we discuss and what is the shortcoming of this theory can be explained on the basis of quantum mechanics. First of all, I want to share what is quantum mechanics. There are two types of physics we can deal. One is the microstructure and another is macroscopic structure. In before 19th century, we discuss in 19th century like classical physics, that are Newtonian physics, everyone know Newton's law. And another after 1905, Max Planck distributes the quantum physics that can be defined energy is always in the formation of discreteness. Here classical physics to fail to explain the motion of atomic and subatomic particle like electron, proton and elementary particle, etc. On the basis of classical mechanics, we cannot explain some phenomena like blackbody radiations, photoelectric effect, Compton effect, theory of atomic structure, nanotechnology, laser, etc. These are the new research. You can see the laser is very important. Today and tomorrow technology and nanotechnology is a part of all the entire region. Here, the question is arise from that, what is quantum? Here, we can understand the some phenomena, how the universe work at the level smaller than atoms, can understand on the basis of quantum physics. That physics describe how the particle that make up to atomic dimension up to nanometers, that can also be based on the quantum physics. Quantum physics tells us how the electromagnetic wave work in a system that deal with the mathematical description of the motion and interaction of subatomic particles, incorporating of the concept of quantization, discreteness or small packet of energy, wave particle duality, uncertainty principle and corresponding principle. These are the basic phenomena that help to understand the quantum mechanics. Here we, because we are discussing a very small particle, some scientists are also based on the experience कि no one can understand quantum mechanics. The famous scientist famous say quantum is too tough is also physics, but with some phenomena we can understand on the basis of this theory can be explained thoroughly. Here the first important article, black body radiation. It is a very new research that only based on the quantum physics classically failed to explain what type of radiation coming from a black body, and all radiation cannot be explained, cannot be studied on the basis of old theory. Here, what is black body? A body can absorb all type of radiations, that is black body. In case of ultraviolet, in case of visible, in case of all type of radiation can absorb black body. As per Kirchhoff law, a body can absorb all the radiation and maintain a constant temperature. It can emit type of radiation. This type of radiation can be explained by different scientists. So we understand the black body is absorb all the radiation that make a strike on it. To stay in thermal equilibrium, it must emit radiation at the same rate as follow. So it is black bodies also radiate as well as per Kirchhoff law. An ideal black body is in thermal equilibrium has two notable parameters. First, it is an ideal emitter. It's like emitter and it's like an absorber. At every frequency, it emits as much more thermal radiant energy as other body of the same temperature. It is diffuse emitter. Measure per unit area perpendicular to the direction. The energy is radiated isotopically independently of the direction. We have a specific spectrum of the wavelength can be understood by the black body diagram. A body is an object absorb all the radiation like a visible, infrared, ultraviolet. But as per Kirchhoff, at higher frequency, classical physics predict that more and more energy would be radiated from the body until the energy become infinite. These are the like a black body, and in figure number 1, we are showing this representation. These are the y-axis spectral radiation energy like watt per meter square, and these are the wavelength in term of energy, and these are the temperature. If we see the diagram, if increase the temperature, we see the graph, the level of shifting towards a shorter wavelength. This type of explanation cannot be explained on the basis of classical theory. Here in figure number 1 that are represented earlier, the spectral distribution of the thermal energy radiation by black body is that pattern of intensity of over the range of the wavelength or frequency depends on the temperature. Conversely, as the temperature of body increases, the wavelength of emission peak decreases. The spectral distribution of the black body radiation come from the different temperature. Two scientists are main observation. Here the Stephens, first we discussion the Stephen. He observed that increase in the emission of amplitude with increasing the temperature, and wind displacement law is observed as the shift to smaller wavelength will increase the temperature. After that, the some conclusion of Stephen's law, the first experimental observation was Stephen in 1879, which is state the total power radiated from the black body that is directly proportional to the fourth power of this temperature. If any body, you can understand with any body can radiate the energy, you can power radiate in term of fourth power of temperature, where P is the total amount of energy per square meter, sigma is constant, Stephen constant, and T is absolute temperature of the system. These are the basic Stephen's law. Again, wind displacement law, the second observation from the was wind displacement law. According to the Wien's law of identification, dominant peak wavelength of light coming from the black body at given temperature, as when temperature varies, so frequency which radiate is most intense. As we see in figure number 1, we can say the lambda maximum directly proportional to the temperature, and these are the constant parameter B, and B is called the Stephen constant, where the value will be 2.89 10 ki power minus 3 meter Kelvin. And more conventionally is obtained in term of micrometer, that is 2900 micrometer Kelvin. This is inversely related to the wavelength and temperature. After some observation, we observe by the experimental data by the Rayleighs, Lord Rayleighs and J. Jeans develop an equation which explain the black body radiation at low frequency. The equation which seemed to be express black body radiation was built up all the known assumption of physics at the time. The big assumption of Rayleighs and Jeans imply that was infinitely amount of energy were continuously added to the system when the frequency was increasing. These expression, like these are the standard notation, these are the experimental data. These dotted curve represent by the Wiens, these blue curve represent by the Rayleighs. Then total radiation of energy by the black body cannot explain on the basis of both scientists. At higher temperature, all the wavelength of visible spectrum are light approximately equal to the intensity. Here we see the three scientists of observation, Stephens, Wiens and Rayleighs, cannot properly explain on the black body radiation, because these radiations come from the black body cannot be explained. It is some validity of shorter wavelength, some validity of longer wavelength, but cannot explain properly. Here, some scientists are observed after that can be explained on the basis of black body. We can discuss in next lecture. I will discuss in the Planck's radiation formula that can be resolve the issue, all the issue related to the scientists that are related. Thank you very much. All the best, my student.